Jai Gurudev student. Today we'll take structural isomerism. The structural isomerism are those isomers which differ in their structure. So what is structural isomer? Structural isomers are those isomers which differ in their structure. Let us take one example. How many carbons are there? 1, 2, 3, 4 carbons are there. So this is your normal butane. Now normal butane, there is also 4 carbons, but you see there is difference in the structure. This straight line and this 3 carbons are in straight line, 1 in the branch. So this is also called your isobutane. So your normal butane and isobutane are structural isomers. They differ in the structure. If you count, all of them contains how many carbon atoms are there? 4 carbon atoms. And if you draw the hydrogens are there like that. So hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen. If you count the hydrogen numbers here, I am just drawing the lines. 1, 2, 3 hydrogen, 4 hydrogen, 5 hydrogen, 6 hydrogen, 7 hydrogen, 8 hydrogen, 9 hydrogen, 10 hydrogen. So both of them contains 4 carbon and 10 hydrogen. They are your structural isomerism. Now another example we are taking, this is your how many carbons? 1, 2, 3, 4, 5 carbons. This is N-pentane. N-pentane with 1 branch. This is your isobutane with 2 branches. This is your neopentane. So all these things are your structural isomerism. Now if I consider, next point is your degree of carbon atom. Now degree of carbon atom is something that one carbon atom if attached with another carbon atom, its degree should be 1. This one carbon atom attached with another carbon, its degree turns to be 2 degree. 3 carbon atom, its degree turns to be 3 degree. 4 carbon atom, its degree turns to be 4 degree. I repeat, this one carbon atom link up with one carbon atom, its degree become 1. Its degree also become 1 because degree linked to another carbon. Now this carbon atom link up with another carbon atom, then its degree become 2. If link up with another carbon, then its degree become 3. Link up with another carbon, then degree become 4. Now in this structure, this carbon atom link up with another carbon atom, so its degree is 1 degree. This carbon atom link up with left 1 carbon and right 1 carbon, so its degree become 2 degree. This carbon link up with another carbon atom, this is degree become 1 degree. Now this carbon atom link up with 1 carbon in the left side, 1 carbon in the right side, 1 carbon in the top, 1 carbon in the bottom. So it will be 1, 2, 3, 4. So it is directly linked up with the 4 carbon atom, so its degree is 4 degree. If this carbon atom link up with 2 carbon atoms, if I put another carbon here, this carbon atom link up with 1, 2, 3 carbon atoms, so its degree is 3 degree. This carbon atom is 1 degree, this carbon atom is 1 degree. So this is how you can give the degrees of the carbon. 1 degree, 2 degree, 3 degree. These degrees are important whenever you are solving problems of carbocation, carboanion, then require to know the degrees of those carbon. Now I have left out this carbon degree will be 1 degree because this one link up with 1 carbon atom. So next we are going to take some preparations. The preparation of alkanes. Alkanes, we know alkanes, general formula CN H twice N plus 2. Now from unsaturated hydrocarbon we can prepare the alkane. Unsaturated, we have learned what the saturated, if carbon atom bonded with 4 other all the bonds of carbon atom are linked up with single bond, then this is saturated. Unsaturated means this carbon atom involved either double bond or triple bond. Now we are taking the example of double bond, carbon carbon double bond, this is unsaturated. Now if I add hydrogen in presence of nickel at 573 Kelvin, that one becomes CH3. Now hydrogen is there, so you can write hydrogen, single bond hydrogen, and there we have double bonds are there, one electron, one electron, one electron, one electron. Remove that one, that becomes CH3. So this is CH3. This is unsaturated hydrocarbon. Now from alkyl halide, term is alkyl halide. Alkyl is something we represent R. Alkyl group will be one hydrogen atom less than the normal alkene. This is CH3 or C2H5. So CH3, CH2Cl link with hydrogen. So addition of hydrogen is called reduction. And in presence of zinc and HCl, that one reacts with this one. This is forming CH3 plus HCl. So this is your alkane is formed. So you can say that one hydrogen replaces one chloride atom. Now Watts reaction, that one is very much important, student. Watts reaction, 1 star, 2 star, 3 star. Watts reaction, this is your alkyl halide. You have to take 2 moles of alkyl halide. Earlier we have taken 1 moles of alkyl halide. Now you have to take, in Watts reaction you remember we have to take 2 moles of alkyl halide reacting with sodium metal in presence of dry ether. Now in this reaction you must remember you have to take dry ether. You have to take what? You have to take dry ether. If you take water and all these things, that one directly converted to alcohol. So avoid using water and all these things. You take dry ether forming CH3 single bond CH3 plus 2 NaCl. So we are starting with one CH3 group. This is another CH3 group. So if I take this one plus this one, they converted, gives you the double one. So exactly one carbon system, we are getting 2 carbon system. So this one is again suitable for even carbon system. If I take another example of Watts reaction, this is CH3Cl, sodium atom, Cl, CH, CH3. Then again you take out this one, then you will get the joining between them. So this is what is formed. So you just remember how to deal with the Watts reaction. This is one of the most important topics. Thank you. Jai Gurudev.